Hello, welcome once again. And how does a starter motor act and operate? This is a pictorial. And before we go to the pictorial, we studied the schematic, a quick glimpse at the schematic, and then we'll go back to it, and hopefully you'll have a better understanding. The main purpose of this starter motor is there are two windings over here. A relay, they call it a solenoid. This starter solenoid is actually a relay. It closes the contacts for the starter motor, and the most important point is for the high current to go through this thick wire from the battery. The low current comes from the battery also, but it goes through the windings and another starter relay. So therefore, low current is here. High current, 200, 300 amps, is through this thick wire that goes through the terminal B, battery, and the other one is S. Now, let's understand a little better. Basically, we're using this to close this to allow that high current to go through the starter motor, and the starter motor is also grounded. Let's look at it a little clearer to understand it. This is the pictorial part of it. Now, as you can see, we spoke before, the battery gives the proper current to the relay, which we call the solenoid. To activate the solenoid, which activates the starter motor. Now, the starter motor over here has something called a pinion gear. Goes to a flywheel, which goes to the crankshaft. The starter motor does not go directly to a crankshaft, in spite of what many people think. It does not. It does not have the torque to even try that, to turn a 8-cylinder engine. It needs a flywheel. But anyway, we said that there's a solenoid, and actually in that picture, if you see that picture, that solenoid is this one, the starter motor is this one, but actually you have another relay incorporated in nowadays. So that's what's missing over here. There should be another relay over here, but this textbook is over 20 years ago, so it doesn't matter. The theory still stays the same. We have a low current. You see the low current? Look at this. See this thin wire? That means there's low current. Through a safety switch, which is the park neutral safety switch on the transmission. Make sure you're in park, or make sure you're in neutral. You cannot be in gear. It means you cannot be in drive. You cannot be 1, 2, 3, whatever, in the wrong gear. So activate this. So low current goes here to the solenoid that we call it, called the relay. The high current now goes from this, from here to here, and to here, through the starter motor, through this solenoid also. You can see it over here, through the switch. So low current went here, high current goes to the solenoid through the contacts, the switch contacts of it. So both go through the solenoid. Low current goes here to activate it, to activate the solenoids. The other one goes through the switch part of the relay that you saw in the diagram. Go back and rewind the video and you'll see exactly what I'm referring to. So now we have two things that have to happen. We just said we have low current by the small thin wire. We have high current by the thick wire going through this, activating this, rotating something called an armature, which will rotate something called the pinion gear to rotate a ring gear, which is much bigger than this one, which activates the crankshaft, the engine. That's fine. Let's look at it a little more closer. Pinion gear, which is smaller? Obviously the pinion gear of this. Which is larger, the ring gear by far, of the flywheel. This can have, in this example, let's say 15 times more teeth. This is called the teeth of it. See? The ring gear, 15 times more teeth than this one. So for example, if this has 20 teeth around this small one, 15 times more, will give you 350 teeth. Just an example. Okay, obviously it's not by this, but anyway, let's just think about that. So, a small one over here, a big one over here, 15 times more than this. What does that mean? That means in order to get one revolution of this, I need this to spin around 15 times. 15 to 1 is the gear ratio. If you know transmissions or you want to learn it, that's how it works. So 15 of these turns will give you one whole complete revolution of this flywheel of the crankshaft. It's a lot. That's asking a lot from him. So that's okay. So the speed of this in relation to this. Now, once it cranks it, approximately, if you look at the gauges, it starts up the flywheel, the crankshaft, or the engine at around 200 RPM. But remember, if this is 200 RPM at the crankshaft, what's the gear ratio? 15 to 1. So if the crankshaft is going at, let's say, 200, and it takes 15 times of this to turn this one, the speed of this is 15 times more than the crankshaft, which means this is 3000 RPM. If the crankshaft turns at 200 RPM, the gear ratio is 15 to 1, this is 3000 RPM. The speed of this is 3000 RPM. I know it's a little confusing. It's not really an important point, but it's just an analysis. You're turning one 15 times to turn one revolution. Okay? So, this has more teeth than this. This speed will be much higher than this. Okay? The smaller one will have to turn 15 times until this one will get to one complete revolution. So, like we said, if the crankshaft is 200 RPM, usually around starting, this will be 3000 RPM. But there's a problem. The problem is that once the engine speed increases, and it'll increase, this will increase 15 times more than this at an overall too high speed. This can go to 10,000, 15,000 RPM compared to this. The armature does not like that. So we have something called the overrunning clutch in the starter motor. Don't want to get too technical. I'll show you a picture of it so you'll understand it much better, hopefully. But you have to understand this part of it. Very important. First, we have to activate the low current in this to close the contacts for the high current to flow, to start this, to start the small gear teeth on the pinion gear, which meshes with the ring gear to turn the crankshaft. Very important. Okay? As you can see, you need a good battery. At the beginning you have 12 volts. But when this cranks all that current, it takes the strength out of the battery. So that battery will drop about 10.5 volts. So if you know that battery is 10.5 volts, you know it pulled a lot of current to start a motor to turn. Or your battery is weak, and if it doesn't turn it, your battery is weak. Maybe the alternator, maybe somebody started to crank the engine thinking it's a no start, but it's it was a crank and no start. When you crank that engine over and over, you weaken the battery. So it's not a no start, it's a crank and no start. That weakened the battery to 10.5. But we're speaking here where the starter motor is working, and if it's working, expect about 10.5 over here. Let's look at a much easier diagram so you'll understand it a little better than what I just explained it. We just said the pinion gear. Think again. This is the flywheel that I just showed you. This has more teeth than this. We said it takes 15 revolutions of this small one to give you one full revolution of this one. Fine. Now, when it gets engaged, when you turn the ignition switch, you're trying to make these two mesh together. Mesh means they make full contact with each other. That's what the word mesh means. So, in this picture over here, as you see over here, as it says over here, this is the plunger. There are two coils over here. a holding coil, a pulling coil. So, as you see over here, the picture speaks better than I can explain. A holding coil over here, and then you have this one. You see this one over here? This is the pulling coil. Two coils over here that we saw in this picture. Remember we saw this picture? See? Two of them. One is a pulling, one is a holding. That's what you see in most diagrams nowadays. Two of these coil wires. That's what that was referring to. That's why I brought this diagram, hopefully to make that schematic a little more clearer, because otherwise it's hard to understand it. So, this shift lever, as you can see, needs to do something. It needs to pull this out to mesh with this. Once coil comes from the ignition switch, as you see over here, like I said, current from the ignition switch comes into this contact over here. There are three contacts. 1, 2, 3. Now, very important, this is the low current that we referred to. The high current has to go through here to get to the starter motor. That's the heavy current. This one over here. This is the small current. It engages this coil. Once it engages this coil, it'll push this out. See the difference? This is not engaged. See the pinion gear? It's not making contact with this. You see the difference over here now? It's making contact, but still, there's a problem. What's that problem? Pinion partially engaged. You can't see that. If you look at it, it looks, okay, they're making contact, but they're not making full contact. And let me show you something that hopefully you'll understand a little better. This is why I use a pen. You see this gap over here? This is not making full contact with it. You see this gap right here? This has to be closer in. When this is closer in, now look at the difference. You see this gap over here I just drew? There's no gap over here. This is making full contact with the flywheel. See the difference? This is making partial. Let me focus. This is making partial. And this is making whole contact. See? No gap whatsoever. That's what you want. If this makes this partial, then you hear those whining noises and all those noises that you hear. It's not being engaged completely. That's what's being happening. So the current comes in, lets the plunger push this against this. We started out with this. Look at the difference. We went from here, no contact, to full contact. This is what you want. Now what happens? What happened? Pulling coil works, holding coil works, it pushes this out, it pushes this out. From here to here, there's a little called contact plate. You see this contact plate? You know what this does? When this works and both coils work, it brings this back against this too. Look right here. See this? Right now this is open. These two are open, these two contacts. When this works, the holding coil works and another one works, guess what? Now the contacts are making contact from here to the starter motor. What will that do? Take a guess. That heavy current that's going from the battery that we started from, now it can go from here through the switch of the solenoid to the starter motor. And that's the picture that we saw right here. That heavy current, the black wire in this one, the black current going through B, going through the contact of the solenoid when this is engaged to the starter motor. Let's look at it closely. If you need to go look at the video to review it. See, no contact, nothing. The heavy current cannot go now to the starter motor. So we need both coils over here. First we have to push it, then we need this to give the current to spin it. So now it's making contact from here to here. From, you could call it B to, you could call this to a starter motor. From here to here. Now we have a path for current to flow. See, now the heavy current has no path. There's no contact. Now there is contact. Now it can flow. We started with the ignition key, the coil, engaging this, giving enough current for this, but we still need the heavy current to turn it. We mesh it together, then we need the heavy current to start rotation on it. The armature needs that. That's what's going on. If you look at pictures, this is the pinion gear. This is sometimes they have something, this is the armature, that's what rotates. And then you have the brushes, and then you have a going out to ground, which is the case is the ground, but the battery terminal goes over here. That heavy current goes in here. This is the solenoid part of it. Remember, we just said 2 coils are activated. When that happens, it closes the contact, and now the battery can now make this spin at a high rate to spin this at a high rate, at to spin the flywheel, at to spin the crankshaft. First this is engaged, then we make it spin. Anyway, I think this was helpful, I think, because it's hard to understand it, but basically that's the easiest way to understand this. So now when we go back to the original one, let's go to the original one. Now do you understand this picture better? Right, I think you should probably, because look at the low current going through the solenoid to right, the 2 pull-in winding, right, the hold-in winding, right? It meshes this with this, correct? It meshes them together. First thing. But that's not enough. We still need a heavy current to rotate it. Then they rotate it. That's when you get that crankshaft to really spin. And remember, 3,000 RPM compared to 200 RPM. When you look at the gauge at the RPM, you'll see it's a low RPM. 200, 300 RPM. But remember, that starter has 15 times more than this speed. I think this explains it much, much better than I can ever draw in diagrams or things like that. I'm good at schematics, drawing those, but not this, believe me. But anyway, thank the viewers that I got monetized. A great accomplishment for myself. Thank you for the support. And when I looked at the revenue today, I made 19 cents, about 8 videos, not bad. That's 19 cents more than I had when I woke up this morning. And if anybody can tell me why, or leave it in the comments, the most highest paid YouTubers, $20 million. Can somebody leave a comment to me? How can somebody make $20 million from YouTube? I would sure like to know that. I'm sure everybody else would like to know that. Maybe Adele? I don't know who, but how do you make that much off YouTube videos? But anyway, please leave comments. If you like this, my views are getting better. I see that. Maybe because because I got monetized. I'm not sure. But anyway, I'm happy. Thanks for the support again. Everybody who supported me to make that possible to me. It was a major accomplishment. Like I said, 8 years ago, I did a few videos. I completely bombed. I said I'll never do it again. 6 years later, I came back. I decided to do this 2 years ago to construct automotive, how to teach people schematics and this, and I think it paid off. Hopefully we'll see. But thanks to all the viewers. It wouldn't be possible without you. Thank you.